There is an unwritten rule in the world of extreme structural engineering and mass transportation. You do not attempt to connect a densely populated, bustling urban city center directly to a terrifying vertical mountain peak in a single, uninterrupted line. The logistical variables, the extreme shifts in weather, and the sheer mechanical force required to pull such an endeavor off usually make it financially and physically impossible. But in the Hunan province of China, engineers decided to completely shatter this fundamental rule. They launched a multi-million-dollar industrial crusade to build the Tianmen mountain cableway. A jaw-dropping continuous steel thread stretching an impossible 4.6 miles from a crowded downtown train station directly into the clouds, terminating at a sheer cliff known as Heaven's Door. With a staggering total ascent of 1,279 meters and a heart-stopping maximum gradient of 37 degrees. It holds the undisputed record as the longest, most physically demanding, and psychologically terrifying high mountain passenger cable car in the world. To understand how human beings could construct a multi-ton steel lifeline over an absolute abyss, you have to look at the brutal, uncompromising reality of high-altitude construction, where every single pound of steel and every drop of concrete was a battle against gravity. The genesis of this impossible machine did not take place in the remote wilderness. It began right in the concrete heart of Zhangjiajie city.
Hold it right there. Watch the clearance on the rail. All right, easy now. Bring it down slowly. Lower it slowly. Watch the clearance on the far side. Okay, hold it steady right there.
To pull a continuous, insanely heavy steel wire rope 7.45 kilometers into the sky, the tension and mechanical torque required are almost incomprehensible. Engineers could not rely on standard lift motors. They had to construct a colossal industrial-grade drive station right in the middle of residential buildings and busy urban streets.
Down, hold it there. Okay, I'm on the shackle. It's loose.
Inside this urban anchor point, giant multi-megawatt electric motors and massive grease-covered steel bull wheels were bolted into heavy concrete foundations, turning a downtown commercial plot into an extreme heavy lifting facility.
All right, steady now. Press it right there. Got it. Starting the drill.
Keep the pressure steady on the valve. Maintaining torque, Visibility is low.
Phase 2 complete, tower steel beginning to arrive, the first tower steel. The section.
Take it easy, take it easy!
Watch the bolts on your side.
All right, easy now. Take the tension on line 3. Got it, tension set. Clear the hook, we are lifting. All right, easy now. Got the connection, send the wrench over. Down easy, down easy. Stop, hold it right there. Clear on this side.
Phase 3 complete. Cable phase beginning. The first cable arrives at the base.
Clear the area. We're starting the main spool. Watch the tension on line 3.
The tension is critical. We have to release the load, now!
When the system operates, these massive wheels groan under the immense pressure of pulling hundreds of tons of steel and human cargo up a sheer cliff face. But the real engineering nightmare began the moment the cable route left the safety of the city limits and collided with the ancient, jagged limestone cliffs of Tianmen Mountain. Unlike traditional ski resorts or mountain outposts, there were absolutely no roads, no dirt paths, and no safe access routes leading up the sheer rock faces of Tianmen. To build the massive steel lattice support towers that would hold the high-tension cable aloft, engineers had to execute a brutal and highly dangerous aerial assault. Heavy-lift helicopters were deployed, acting as airborne cranes. In a series of high-risk maneuvers, battling unpredictable thermal updrafts and blinding mountain fog, these helicopters airdropped massive portable generators, heavy steel I-beams, and industrial drilling equipment onto narrow, lethal ledges. But the helicopters could not do everything. In zones where the wind shear was too violent for rotors, the project relied on raw, grueling human endurance. Laborers literally carried hundreds of pounds of steel on their backs, inching their way up the treacherous near-vertical cliffs. Workers, suspended like spiders from thin safety lines over a terrifying 4,000-foot drop, wielded heavy pneumatic drills, boring deep foundation trenches directly into the vertical limestone. They had to pump thousands of gallons of high-strength, fast-curing concrete deep into the mountain's crust to anchor the towering steel pylons on a terrifying 37-degree slope. One minor miscalculation in the foundation's load-bearing capacity would mean the entire steel tower could rip out of the rock under the extreme tension of the cable, sending everything crashing into the valley below. Once the skeletal towers were permanently bolted to the mountain, the project entered its most lethal phase, stringing the 4.6-mile high-tension steel cable. You cannot simply carry a continuous wire rope of this magnitude up a mountain. The main haul rope is a massive, multi-layered beast of braided galvanized steel, weighing hundreds of tons. Pulling it across a 1,200-meter vertical ascent requires staggering mechanical force. Engineers first used a lightweight synthetic guide rope, pulled by a helicopter from the city center all the way to the mountain peak. This thin line was then used to pull a slightly thicker steel cable, which in turn was used to pull the final massive haul rope. This process took weeks of agonizing, high-tension pulling. Massive industrial winches stationed at the top and bottom of the route screamed under the immense pressure. As the thick steel thread was dragged up through the clouds and locked securely over the massive sheaves of the support towers, the mechanical stress was palpable. If the tension snapped during this process, the 4-mile steel cable would instantly become a lethal supersonic whip, capable of slicing through concrete, steel, and anything else in the valley below. To prevent the cable from swaying violently and derailing during high-altitude mountain storms, engineers integrated massive hydraulic dampeners and heavy-duty wind deflection guides on every single tower, allowing the massive steel line to flex and breathe with the severe mountain winds. The final operational result is a 28-minute psychological endurance test, masquerading as a tourist attraction. The experience is engineered to induce pure vertigo. Passengers board the cabins in the bustling, noisy concrete jungle of Zhangjiajie. The doors lock, and the cabin glides silently out of the station, passing directly over city streets, residential rooftops, and a massive railway station. For the first few miles, the ride is deceivingly horizontal. But as the cabin leaves the city behind and enters the shadow of Tianmen Mountain, the reality of the engineering hits. The cable violently angles upwards, transitioning into a terrifying 37-degree vertical climb. The ground drops away with sickening speed. Suddenly, there is absolutely nothing beneath the cabin but a 4,000-foot drop into a misty, jagged abyss. The cabin slowly creeps up the sheer rock face, piercing the thick mountain fog, suspended by nothing more than a few inches of braided steel. As the cabin approaches the upper terminal, passengers are brought face to face with the Tianmen Cave, the colossal, naturally formed archway known as Heaven's Door. It is a breathtaking, terrifying triumph of extreme altitude engineering. China didn't just build a cable car. They forged an impossible steel lifeline, bridging the massive, terrifying gap between human civilization and the absolute limits of the sky.